Yesterday's class in pandas and all, like we have seen group by and statistic parts, individual statistics, all this group by statistics we have seen. No doubt. Are you guys understanding?
Yes.
Okay, good then. So in the last class, we have seen the group by, what the importance of this group by is, and then we have seen some kind of a statistics how we can do, right? What are the individual statistics are there in the group by, right? And the next topic, when we talk about the statistics only, one of the important topic is like we are working on the number, relationship, and all these things. So after group by, one of the important thing in the statistics, or we can say applied statistics, is the correlation. So what correlation give? Correlation gives the linear relationship between any two numeric variables. Okay. Let's say, for example, I have some value here. Okay. And here, let's say temperature here, and here is the NDVI, something like that. Okay. NDVI or something. Or let's say this is a NDVI from remote sensing, and this is the NDVI from any, no, we will get it from the remote sensing only. Let's say this is the, have you heard of word leaf area index? Or let's say
Yes.
this is the soil moisture, right? We had a soil heat flux and soil moisture we can measure in the field, and this is also soil moisture from the remote sensing. So this is the predicted from remote sensing, and this is the predicted from observed value. For example, we are getting some data points here. Okay, some data points we are getting, and we want to understand that how this predicted, or that remote sensing soil moisture is correlating with the observed soil moisture. Okay, is it like all the values are perfectly aligning with the observed soil moisture, or like the it is under predicting, all the values are above the this particular line, or it's like over predicting, all the values are below. So correlation is again like one of the important, we can say, important method. Okay, because it gives us the relationship between two value. Either it can be same. Okay, let's say if I want to see that because of population, how much area I am going to, after next 10 year, let's say because of population now this much area is in 2026 this much area, and 2036 is this much. So what is the relationship between this area and this area in terms of population? If population is increasing, so do I have to increase my area also? Okay, so this kind of relationship things can be solved by the correlation, right? So in correlation, value ranges from -1 to +1. So, so what it is? It measures the linear relationship between two numeric values, variables. Okay, and like here, one variable was soil moisture from observed value, and other was in the y-axis was soil moisture from the remote sensing, something like that. Another important thing is it ranges from -1 to +1. Okay, it ranges from -1 to +1. I will make it marked down only. So what -1 will say? Minus will say that there is no relationship with, or we can say perfectly negative relationship between. Let's say like we are understanding how two variables are moving together. For example, I have some x values. It is moving like this. Okay, this is the trend it is following. Then I have this is x. Okay, and I have a y value also. This is also moving like this. Okay, somewhat value. Okay, this is y. So both the patterns are performing, both the values of x and y are giving the same trend. Let's say x is like this. Okay, and y is like this. Here what is happening? Here it is, here we are having the opposite, we can say, if x is increasing somewhere, that time y is decreasing. If here y is decreasing, here x is increasing, now here y is decreasing, increasing. So this kind of pattern when it is following, it means if x is increases, y tends to increases. Here when x increases, y tends to decrease. Or let's say here if x is moving like this somewhere and y is going somewhere here. So this is what, there is no consistent pattern here in x and y, right? This is positive pattern we are getting. Here negative pattern we are getting. But here zero, no consistent pattern we are getting. Okay, so when do we get the positive value? When we see that there is a similar trend in both the variables, right? Or we can say when we have the perfect positive correlation. When one goes up, other also goes up. When one goes down, other also goes down. But in minus, like -1, both the trend are going opposite, right? So especially when you, I don't know how many of you have done the feature analysis or something like that. To run any model, we have to work on, we have to calculate the feature importance thing. Okay, like here, for example, if I'm calculating anything, any variable, let's say ndvi only. Now if my ndvi is going up, I can say that my greenness is also going up. Okay, and let's say temperature is also going up. Okay, for example, something like that. But let's say soil moisture or any other of the factor, it's going down, right? So what we are finding that, okay, there is a relationship between ndvi and a greenness factor. There is a relationship between ndvi and temperature. But there is no relation, but there is either negative relationship between ndvi or a uh, soil moisture. So how this helps us now? This helps us in understanding the feature importance when we are calculating anything. Now if I'm saying that, okay, my this value is going, if I have to calculate x, my this value is going in this trend, this y value is also going in this trend. But let's say z value is there, who is giving us the negative correlation, or y or any a value is there, who is giving no no correlation. So we can avoid those features, we can avoid putting it in our model like that. So what positive do? Positive means perfect positive correlation, right? If one variable go up, then other also, then other will also follow the same trend. Okay, so I'm writing other always grow up. Then -1 is negative positive, sorry, perfect or negative correlation. It acts opposite. Okay, if one go up, other go down, right? And zero means there is no relationship, or there is no correlationship or no linear relationship. So zero means no correlation or linear relationship. So this is important when it comes to um, testing any model, when it comes to validating anything. Let's say I have created a some model. Okay, I have observed, I have predicted some value. Like for example, I have predicted, let's say, evaporation, for example. Okay, or any other value, right? So now I have a observed value from some, let's say, rainfall only. Okay, let's say IMDb predicted the rainfall value, and from the weather station I have got some observed value. Okay, so we always validate, or we always find the correlation against the observed. So on a x-axis we will keep the observed value, on the y we will keep the predicted value, and and then it will follow some trend, and it will give me the r square value. Like, have you ever calculated the R square in the, Excel sheet? Any of you? Have you calculated the this thing? I will show you how we can,
No.
like a calculate. I'll show you how we will get the data. Just a minute. I'm just, let's say this one. This is the TIFF file. Mm, It's the Excel sheet. Yeah. This image, can you see? Yeah. So here what? This is like the GPP I calculated. GPP is the gross primary productivity. It means how much amount of carbon a vegetation or a crop or any, like a plant is taking during photosynthesis. So this thing I got from the tower, and this I predicted. So two models I have run. One is underlying water use efficiency and one was a light use efficiency. Okay, so this blue one is one model and a green one is another model. So here, and so the what is happening here? Here, let's say I have got a trend like this, something like this. Okay, this is my observed GPP. This is my observed one, and this is my predicted one. So can you see the way I'm getting the scatter plot? And here I have calculated the R square. So this R square here is giving me the idea that how much, like the how much my this model is correlating with the observed values. Okay, and how much my second model, this LUE model, is correlating with these observed observed values. So now here you can see this line. Okay, this shows some kind of a linear relationship. Now here this value show that most of the value here are what, like it is under predicting. Okay, this value is, if this is the one on one line, okay, most of the values are below this green dots are below this particular. Let's say this is the, let me I have not shown here one on one line. So from 0 it will go, let's say from here till somewhere here. Okay, so here we can see most of the green dots. Okay, observe the green this square dots here. Okay, what it are, these are under this one on one line. Okay, it means my model is not predicting, or like near to the one on one line, where you can see this blue, this thing. Okay, here what it is going up. Okay, so much values are either it's near to one on one, or either it is over predicting the value. Let's say if my tower value is 2, it is saying around 2.5. Let's say for blue one, let's say for my tower value is 2 for this, but for this it is calculating 2.3. So the more nearest value it will be, the more high r square we will get, right? So in this way you calculate the in this way you calculate the this correlation thing in the python. This is the python plotted plot only. Like you can then if you have this much points, you can plot the like a scatter plot like this, then you can easily present your work like this. So here, like for example, here I have calculated the r square, then there is a RMSE also, which is root mean square error, and then there is a bias also. Okay, so bias will tell what how many values are predicting, under predicting, and all this thing. So right. So here, when I'm saying my in that image, I was getting positive value only. Okay, so but not near to 1, it was around 0.4 and 0.5. The more value we will get near to 1, it means the more perfect correlation we have in both the values, right? Now, let's say, now there are, okay, let's say I have some example. We have this population and area thing, na? Uh, okay, let me rerun that file which I have. DF. Here, okay. No, this is the NDP sample. Hmm. Okay, this one, right? Okay, PD again. Yeah. So let's say I want to find a correlation between the this thing, area and population, right? So how I can calculate that? Simply DF population, comma, area, km square, kilometer square, and let's say, okay, dot CORR. So what this dot CORR, it will calculate the correlation between this column and this column, right? So if I run it, so for population to population, it will be 1. Okay, like, okay, this is, let's say this is population and this is area. Okay, and we have some population points and we have some this points. Let me tell you how actually the correlation is calculated. There is a formula to calculate the correlation. Okay, then only we are getting that value. Yeah, something like that. I think correlation statistic, I think. Same only. So here x, summation of x into y minus summation of x into summation of y. Okay. Then square upon square root of number of values into summation of x square minus summation of x ka whole square minus into summation of y square minus summation of y ka whole square. Okay, so this is the critical formula we have for the calculation of the correlation coefficient. Now there are two type of correlation coefficient. Here it is writing Pearson correlation, right? Another one is a Spearman correlation. So now here when I'm not defining any kind of correlation, in default it is taking it as a Pearson correlation. Let me tell. There are two types of two types of correlation for a matrix we can calculate. One is Pearson and another is Spearman. Let's say this is the this part and Spearman correlation formula. Then this is the Spearman and this is the mm, Pearson correlation. Okay. So what Pearman actually is based on the ranks. Instead of using the raw value, what it do? It gives the rank. Rank means, let's say if high value is there, okay, if there is a, let's say, uh, it converts a value into the rank and then it computes the, what to say, Pearson relationship. If, for example, if X is increasing and Y is increasing, still it is even a non-linear, Spearman will say high value. So if a relationship is messy but still in order, Spearman will capture in the better way. Okay. So here if I am not defining anything, that means it is by default. Here if I am not defining anything, it means it is by default a Pearson. Okay. Understanding?
Yes, yes, Sakshi.
Yes. So, like I told you, now what it is, this side population area, and here we are population and area kilometer square. So here I have not defined anything. So this is by default Pearson. Okay, simple. Then another thing which I told, what's like I told you, Spearman, what it do? It based on the rank. So how rank it will give, like what it will do, it will sort the position. Okay, no, like it will first sort the data and based on the data it will give the position. Let's say for example I have X is equal to 10 comma 20 comma 30 comma 40. Okay, so it will give the rank like this: X rank is equal to 1 2 3 4. Okay, and let's say Y, I have Y is equal to 40 20 30 20 and 10. Okay, so it will give rank like 4, sorry, yeah, 4 2 3 2 1, something kind of rank it will give. And then no, I think it will give 1 2 3 4 only, because it is showing the negative, no? 1 2 3 4 like that. And then based on this rank, it will calculate the Pearson, and then it will show the whether it's a negative rank or the positive rank it is showing. Okay, like that. So that's why Spearman don't care about the kind of value what you're. It only cares about the numbering. Okay, it only understand like what kind of no, ranking we are following, or how much it, like what kind of ranking it is following, right? And then based off the ranking it will take the value as the this thing, and then it will calculate, right? So to calculate the this thing, to calculate the uh, Pearson, how we'll say, df dot core and inside method is equal to Spearman. So here what? Here I am defining the method, right? So if I have not defined the Pearson, if I am not defining any method, then it will calculate as the Pearson. But here I am defining the Spearman like that. Okay, sorry, here, oh, to whole value, sorry. This thing I'll do, right? So now you can see the values have changed now. Okay, the both the thing are giving us the different value. Now earlier it was 0.7, 0.07, now it is 0.24. So our correlation has now uh, been become a better. Okay, so when there is a more robust data, or there has been outliers, or the data has not been normally distributed, that time this Spearman has been really useful. It will capture the ranking, or it will capture according the value of the number, and then accordingly it will calculate the correlation. While here it is calculating just based on their relationship. X is this, y is this, based on such thing we are calculating. Understanding? Okay, so when there is a linear or something kind of when we have to measure a linear thing, then go with the Pearson. Or when there is a like a when it is sensitive to outliers or something kind of thing, then also when we have to go for the non-linear, if we have to follow the non-linear thing, then go for the this Pearson. Okay. Distribute. Okay. In the correlation, one of the, again, like here, what we are doing, we are taking two variable. Okay. Let's say any two variable I have, and based on that, I am calculating the this thing. So what we are doing, let's say if I do DF population dot core DF area kilometer square. Now here what I am doing, this is called the single pair correlation. It will return a float. So what is happening, that Pearson R is between the population and area. So this is useful when you have to just need a like a one specific relationship, right? When you want a one specific relationship, like whether it is positive, which is perfectly increasing, or let's say negative kind of thing. So especially when you have a two variable, and we have to understand how they move together, that time, what did I do? Mm, DF core area. Acha. Okay, so here I'm getting only single value. Like this, I'm not getting. Okay, so here I'm getting R square value directly. Okay, here it is telling relationship between population relation, same only, whether you keep it like this or like this. Okay, same relationship between area kilometer square is this. Then here we are getting the single pair. Okay, single pair correlation. This is single pair correlation. It is directly giving me what is the relationship between the population and the area, how much they are correlating, how much there is a relationship between those any two parameter. Direct a specific value, one specific value, or we can say one specific relationship we are getting here. And this value is nearby zero. So we can say that there is no correlation between the we cannot say if population is increasing, area is also increasing like that. Like, or let's say if we do it between population and density, then we will give 100% or we will get the one value. Why? Because we have calculated density based on the population only, right? Or so that time we will get the good correlation. But here, let's say we have calculated that thing now, understanding, or also we will get the relationship between area and density also, right? Let's say df density, I'll calculate it here, is equal to df population upon area, upon df area. Okay, just for the example, I'm not converting any value or something. Like this we are getting now. Now let's say, let me calculate this for the df population, and instead of area I'll keep df density. Okay, so okay, I think we are dividing it by area, so we are getting a different value. So this is also not like we cannot say if population, we should get it like that, but let's say area, or we'll say density here, same only will get. Okay, same only we are getting. Let's say area, if we keep, we are dividing it by area now. That's why, see, now we are getting the negative relationship. Okay, it means if density is increasing, area is getting down. Okay, area is getting down. If we are increasing population, then density is not working because we are dividing it with the area. If it was a multiplication, then because now the values are getting changed based on the area. Since area is going down, so density also we are not perfectly correlating with the population, right? So this is how the correlation thing works. Another thing in the correlation matrix only to understand is the covariance. So now instead of two variable, if you have so many variables, okay, now here you had a population area, but for example, if you want to, if you have a population area, air let's say temperature, or wind velocity, any or let's say count, or any number of value if you had. Okay, so what covariance do, it measures the joint variability. It means if it is positive, okay, so both increase together, same only. Negative means one decrease, one other, or zero means no consistent joint variation. So unlike correlation, covariance is kind of a scale dependent. It is not based on the normalized value, right? For example, if so, um, it is when I'm saying normalized, uh, like like when we say, it is like when we are, for example, perfectly it is going to -1 to 1, so related to correlation but not normalized to -1 to 1. Okay, we can get the values, like we are not in that particular range, but we can get, depends on the scale of the variable. Okay, like that we can get. Let's say here we are calculating covariance. I'll take the same example. This one. Now instead of core CORR, we are writing here COV. Okay, so this is giving, oh my God, a kind of how much it depends on the scale of the variable. Let's say I'll add it here, density also. So see, the when we have a number of variables, the more number of variable we'll add, the more it is giving us the like we can work it on a, like here if we are calculating only for two variable, but here we are working on the uh, another more than a two or three variable, right? So covariance matrix is like a full matrix we will get, or when we have a many variables, that time we can use the covariance matrix. And it is not giving us the normalized value, it is giving us the normalized value means not giving the value in from -1 to 1, but giving the value as per their scale. Any doubt?
No doubt. So far, so good.
Fine. Understood covariance? Fine.
Yeah, yeah, got it, got it.
Hmm. Okay, everyone understood, right? Huh. Right. So here if you can see, some of the values we are getting negative also, right? If both the value, like here, this is in relationship between density and area, right? So here it means both the values, like one is increasing, another and same, like here in the same way, like the it was working with the uh, co- uh this thing correlation thing, same way it is behaving here also. Now after the what to say, after the correlation and covariance, another topic is the, that is the group by statistics we have seen yesterday. I'm just telling you the one more thing, that is the rolling windows. Now, what rolling windows do now? Let's say, uh, okay, let me draw something. Let's say I have a daily data. Okay, something like this. Any data. Okay, let's say temperature data or any data like this. I have a daily data like this. Okay, this trend is going like this. Now, what rolling windows do, it calculate the compute statistics over sliding a window of row. Okay, let's say this is a one row value, this is another row value, or let's say here we will have so many rows like 1 2 3 4 5 6 7 8, and combining all, we are getting this kind of a trend. Now what rolling window will do, now how it will slide over, do I have, yeah, what it will take this as a one window, let's say this is 7-day window. Okay, so it will compute the, let's say mean value, if I want a mean rolling window, then this is my one window, then this is after 7 day, 7 to 14, this is my another window. Okay, now let's say this is my one another window. Okay, sorry, it should be like continue, there is no gap like that. Now how I'll get my trend, now my trend will be according, let's say combining this, I'm getting something value like somewhere like this. Okay, and then again here it is increasing, then here it is something like that, it is happening here. So now what in a rolling window happens, that either it's a moving average or a standard deviation or a cumulative sum. Okay, so what I am doing, I'm making a window of the, and I'm calculating a compute statistics over this sliding window. You can calculate it by the by averaging this values, or by averaging this by summing this value, and by this thing. Now, why this rolling window is important? Because when it comes to, like I always uh, told you that when it comes to real time data, there will be a lot of noises in the data, lot of spikes, not spikes, but like here it's not revealing kind of a trend, but to get a smoothness of the trend, we do the rolling window thing. Okay, to capture the smoothness of the trend, we calculate the, we do the rolling window means. So what rolling window is, like for example, take a fixed size of subset. Here if I'm taking a 7 day, and 7 day for my this particular data, and it is moving a step by step. Okay, so this window is now first for the 7 day, then next 7 day it is calculating, and then next 7 day, right? Let's say I have a simple, I'll say for example, let's say I have a data like this. This is again important for a statistics, because when it comes to showing the data, okay, you, let's say you have 2 years of data, and you cannot show the daily data kind of thing. You can completely average out. Okay, like I told you, using the group by, you can convert the this thing, um, daily into 7 days, 7 day into monthly. But what it will do now, let's say if I use group by, it will give me values like, let's say something like this, okay, and then here it is like this, something it is giving. Now what this rolling window will do, it will, or either it is very peak or something, like not like this. Okay, now what rolling window will do, it will smooth the curve. Okay, it will smoothen the curve, and will give the trend like this. Okay, so what we are doing here, instead of computing anything on whole data set, we are computing it on a small window, right? And then while plotting the trend, that trend is getting the smooth. Okay, like there is no smoothness in the trend we are following. When we are having this wave like structure, then we are getting the smooth follow trend. Let's say I have a import. I have already imported. Let's say I have a simple data is equal to 10, 20, 30, 40, and 50. And I am converting it into a series. Okay, because I have a one array data. So let's say S is equal to PD dot series and data. Now I want to do mean. So rolling is equal to S dot rolling. Then how many windows you want? Let's say I want 2 windows or 3 windows. Windows is equal to 3 dot mean. Okay, and then I'll print rolling. It is window, not windows. Oh, I'm not given a parenthesis, sorry. Yeah. So now you can see how it is, what actually happening is here, that window first two is the like first two value is the nan, because there is not enough data for that. Okay, now then in the second it will go 10, 20, 30. Okay, then in the so it will take mean of 10, 20, 30. Then it will take a mean of 20, 30, 40. Then it will take a mean of 30, 40, 50, like that. Okay, so here when I'm saying window 3, it looks at a 3 value at a time. So first what, it will take a 10, but with a 10 it will first check, but with 10 it cannot go ahead. Okay, this window, because here window is 2 now, so here first two value means it is taking as a nan. Then again it will go to 10 and 20, but now again here we are not getting a combination or a window of a 3, so that's why again it is a nan. Then it will take 10, 20, 30. Okay, so now it will take a mean of 10, 20, 30 and will give us the 20 value. Then it will go on 20, then it will go on 20, 30, 40. Similarly, then it will go on 30, 40, 50. So it looks at a 3 value at a time. It will start from 10, but it will not like 10, 20, 30, it will directly start. It will like first to when it will come on 10, it will check that whether there is enough data, or like going moving ahead or something like that. Okay, so but when we are working with the time series, okay, and what rolling will help, like I told you, smoothing, detecting the data, computing, averaging. Okay, so it should also have the enough data. So sometimes in while working in the time series data set, something like that, we can get the starting value as a nan or a this thing, but as soon as it will go forward, it will give us the smooth curve. Okay, and it will based on the, it is taking all the values, and based on the all values it is getting we are getting the output return. When it comes to for example time series data, where we have a like this thing, let's say time date thing. Okay, and you have to do time based rolling in there, like above we have done with the um ndvi I've shown now. So for that, let's say then s rolling will be s dot rolling, and instead of window you can directly say, let's say I have to convert 1d into 7d, like not convert, plot. Okay, 7d. So instead of windows is equal to 3, we will say 70 and will directly take a mean. So this is what, this is row based, and this is kind of a time based, right? Let's say we'll see the population thing. Oh, sorry. I have a area and population. Let's say I want to df population dot rolling, then window is equal to, let's say 3 only, I'll take 3 dot mean. Okay, and it will directly get no, not df dot population, df population. And this is okay. So now what is happening here? First two value will get none. Then it will check second, uh, third and fourth value. This value will get. Then again, third, fourth value. If there is a nan in between, then it will give nan again. So it will keep on going and going and going. Now here, if I found a nan, then it will giving me the nan and all this kind of thing. So when I'm like doing this three, means like I'm doing the 3 period moving average. So each values is the mean of that row and the rows before it. Okay, first row and 2 rows before it, nan. Similarly, this row and two rows before it, there is no value there. That's why the first two rows will be nan, because there aren't enough prior rows is there. Then it will go to third row, fourth row, fifth row, and depending on the data, it will give us. Let's say instead of, I'll do oh sorry, okay, stop. And let's say I'm rolling window is 5. Wait, my laptop got hanged. Mhm. Right. So here now, first three value is nan, and after that we are getting, if you plot this and plot mean, you will find the smooths out short term fluctuation than the this spike kind of thing. So for a visualization purpose, majorly this rolling thing has been, you people use this rolling thing. Then another thing is the in the rolling, let's say if I want to calculate instead of mean, kilometer square dot rolling, let's say window is equal to 7 dot std. Std means standard deviation. It will 7 period window will roll and give like based on the standard deviation. So where did I go wrong? Okay, here. Right. And then it will tell the measures kind of how much variation it is having with respect to mean and all that thing based on the um, standard deviation. Another thing is the cumulative sum. Now DF, let's say population I'll do. Mm. Now here, actually cumulative sum is kind of this only. Let's say I have a value like 1, 2, 3, 4, 5, 6, 7, something like that. So first value will be 1, second value will be 1 plus 2, third value will be 1 plus 2 plus 1 plus 2 plus 3, fourth value will be 1 plus 2 plus 3 plus 4, and it will keep on going. Okay, so this is the cumulative sum. So each row contains the running total of all values up to and including the row. Okay, so for example, if you have a monthly sale, so CumSum will give you the year to date total at each month. Okay, so for here I'm not applying CumSum rolling, where directly if you have to calculate the cumulative sum, you can say df dot. Okay, so it's giving me the, let's say if I add it in the uh, rolling way. So it is saying that rolling has no object attribute, this cumulative sum. Okay, so we are having mean, standard deviation, okay, addition, or we can say this thing, but this cumulative sum is not the attribute of the this thing. Now similarly, uh, with a, like a cumulative sum, there is the another that is cumulative maximum. So it will like show each rows the highest value it has been seen so far. So specially it has been used when you have to track the all-time highs value and like something like that. So in this particular like population column, this particular value is the highest value. So that's why for all the rows it is printing that particular high value. So here each row will show the highest value of that particular column. Okay, like that. Then any doubt with the rolling and this come sum and come max thing? So we'll move to the next topic, that is the filtering the data set. Okay. So now we have seen inspecting the data set. We have seen editing the data set. Okay. And we have seen how to group by the data set. Okay. The another topic is the how we will do the filtering. Now, when I say filtering, have you remember we have seen LOC, dot ILOC, okay, like in the here only some like how to check the data and all this thing, okay. So now filtering is how you extract the subset of the data, okay. If let's say we have seen in when we started the pandas, we had the like we had the here we have applied some we have customized the this thing, like I only want two columns, I don't want I have a 10 columns, out of that I only wanted two columns, okay. So what I'm doing, I'm extracting the subset of the data, okay. Now, so what panda gives, like if panda gives the four complementary approaches for filtering the data. One is the boolean mask, another is uh, the query dot query, we'll see, another is the string method, and the other one is the this loc and the dot loc. Now this boolean masking is the like again one of the, we can say, most fundamental filtering technique, because when I'm saying boolean, it means what, I'm getting a output as a true or a false, okay. How? By either by conditioning or by asking whether any value is satisfying or having this particular value in that, okay. So what we let's say you create a true or false array by any giving any condition, and then we are using that array to index the data frame. So only rows where the mask is true is getting returned. We have seen above also that it happened that wherever the mask was true, we were getting wherever the boolean answer was true, returning the true, we're getting that particular values also. Similarly, in the boolean mask also it will follow the same technique. So the next is to filter the data. Filtering the data, right? Now here, like I told you, four approaches are there, okay, to filter the data. First is this boolean mask. Second is dot query array or dot query string method. Then third is ILOC, and LOC we have seen this already, we'll see it again. Uh, Boolean mask, okay, like uh, this thing, ILOC and LOC. Okay, so first is the Boolean mask. Now here, what we will do, let's say, um, for example, mask is equal to df population, let's say greater than mm, let's say 2 lakhs. I'll keep 20 lakhs, sorry, 20 or 2 crore it is. 8, 9, 2, two more zeros. Okay. So what this will do, this will create a Boolean series. So wherever the population will be true, wherever the population will go this above this value, it will print true, or else it will print false. Right? Okay. Now let's say if I do df, or let's say df only I'll create. So now, oh, we have not saved it here. Let me do like this. I have not created a, what to say. Oh, sorry. Skis quotes. Hmm. So see here. So now based on the this condition, we have created a kind of a series. Okay. Here and added a. This will give the series, since this particular give me the series, and this series I have added in this particular df file. So wherever this population is going above this value, it is true, or else when there is a no, then it is giving us the false. So what we are doing, we are passing the Boolean series as the low index, and then Panda will, let's say if I simply do df mask, okay, so what I'm getting, like, I'm not getting, okay, it has been saved it there, okay, fine. Okay, so we are getting one index, and based on this index, then we can now filter the particular thing. Okay, then if it is true, then that particular value is greater than this thing, then it is returning the true thing. Now, if I do like this, df population greater than 20. Hmm. So this is what happening here is, this is called the inline version. This is like most common practice in the like in the uh, this when filtering the data. Here what it is giving only me the it is only giving me the values where the this mask is kind of a following that particular like the when both are kind of equivalent, like if it is true, then only it is giving me that particular value. Okay, if I say like this, okay, and if I put and here, let's say I'll say and df area kilometer square and less than 2000, let's say. How much area is this? Hmm. df two times. df population greater than, this is the first condition, and then after and this is the next condition. So we have applied a and here. So and means what? If this both the condition are true, if like, then only it will return the true values, or else it will return the false value. Okay, so it is checking only those value and giving us only those value which are following this particular which are satisfying this both the conditions, where population is also greater than this value and area is also less than this particular value. If let's say instead of and, if I put or, so putting or instead of this sign, I'll put this thing. Okay, this is for the or operator. So now what? Either greater than, if so, if any of the value is true, it will print that particular, if that particular thing. Okay, so if it's greater than value, or if it's less than, it's gonna print that particular thing. Or if understood. So this is how you do filtering. Another way, you know that we use the uh, not operator, or assigning operator, sorry, comparison operator, equal to equal to. If I do df, this value, this tied value is the not operator for array. Okay, and if I do df country, let's say, and equal to India. So wherever there is a no India, it will, okay, wherever there is a no India, it will say false, and wherever there is the India, sorry, why it is saying true to Japan, not df country only. Is there a country name India? Let me. Oh, we do not have the country name India here. Let's say I'll keep Japan. Oh, there is the India here. False, 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 false. Why it is saying true to China? Mm, Actually, what this do, it will return all the rows where country is not a Japan. Okay, and if I do it like this, just a minute. Instead of this, if I say df, and I will say, we used to write it like this also, not equal to like this, country. Let me see. Let me rerun the df again. Something happened. Let me run it here only. df is equal to pd dot read underscore csv. I'll copy that file. Input data. Okay, and now let me run it. Let's say Japan. Yes. So Delhi, India, we are getting now. So see, it is kind of a not operator we are using. Okay, we are not using equal to operator. Okay, so it is going to return the values. If there is a Japan, it will not return. But if it's not Japan, it is going to return that particular values. Right? Earlier there was some issue because we were doing so many things, so kind of malfunctioning thing happened. But here you can see now, are we getting Japan here? I don't know what is happening. Just a minute. Delhi, Shanghai, Asia only. Let's say, I'll say continent. Continent, and I'll say Asia. Yeah. So now, uh, instead of those continent, every continent is getting printed. Right? So this tide, or if you write it like way also, one on like same only. Okay, this is both are equivalent, same only. Either you write tide or you give this thing, both are same. Okay, so what it will return, all the rows where this continent is not Asia. Okay, so there, this is not Asia, so it's getting returned. This is not Asia, so this is getting returned, kind of thing. Right? So this is how you filter the filtered in the Boolean mask. Any doubt here? Now here I have done df, that's why we are getting output. If you have written it just a one time, then you could have get it in a true and false situation. Now we are printing the true values only. Okay, that's why this df, wherever the value is true, that column, that particular rows are only getting printed. Right? Now let's say another thing is the in the filtering the data set is the query. Now, when I say query, this is kind of another clean way to filter a data using the conditions only. So, why we use query? First is to, it has a cleaner syntax, especially when it comes to multiple conditions, it is easier, right? So, let's say, like here above we were calculating the population only, that if population is greater than this, calculate, give us the true and all this value. Now here what will happen, that the query will we will uh like we'll filter it using a string expression. String means, instead of the boolean thing, that population greater than 25, okay, we will use it as a string. Let's say df dot query, we will make it a string here, population. Earlier we were writing like this. Okay, let me say, let me tell you, earlier we were writing like this. If df, or like here only, how we have wrote, like this we have wrote df, df population greater than, sorry, let me close this, population, and that too in string, right, greater than 2 and something we were writing. Okay. Now okay, instead of instead of this, how we will write? Df dot query, either one string or two string. Okay, anything is fine. Population greater than, okay, and we'll close it. So what we are doing it, this is the string and it is evaluated now as a Boolean expression. Okay, so no need for df population. You just use the column name directly inside the string now. Okay, we'll directly use the column name inside the string. Let's say we'll run it, and what we will get, the population will get only those rows where the population is greater than this particular values, right? So now what, instead of df writing two times this kind of thing, writing this kind of all these things, what we are doing, simply we are writing df dot query and population greater than this is the true. Similarly for this example where we have put the population and area also, like somewhere here we have put, yeah, here, here, okay. I'll copy the same thing. Like here we have seen df, then df population greater than and df area greater than. Then how we will write this? Simply, instead of writing all these things, I'll simply say df, I'll remove the square bracket, df dot query population greater than this value and area. Lastly, I'll keep the, close the this thing. Now what I have written, population greater than this value and area kilometer square less than 2000 value, sorry, parenthesis. Okay, so now inside this query strings we are using, and you can use and, or, not, as a whatever the regular Python keywords we have used, that we can use. But instead of writing like this, making the condition df population, df area, df that, all that, instead of that I'm simply writing the query, and what my query is, I'm just simply writing that. Okay, so I'll get the uh I'll get the values where both the things are following the true, because and is there, so this is also greater than true, this value should be also greater than, and this value should be less than, then only we will the output will get written accordingly. Understood? Now we can do in another way also. Like here we have put here the value. Let's say I have, instead of this value, I will assign this value or constant, we can, constant, let's say threshold is equal to some 2, like this I'm keeping. Okay. Sorry. Okay, this is my threshold value. And I'm saying df, let me run it again. You can do Control Z, so you will get your old values back if you will do Control Z. I hope you will do, like, Control Z is for the undo, doing undo. So df dot query, and now how I'll write population greater than, now directly writing we will use at the rate. So this, what at the rate symbol inside query reference on an external Python variable. Okay, like this at the rate threshold. So evaluate to this particular value. It will evaluate to that particular value, right? So here we'll write the and we'll close it. And then we'll print. So again, wherever the value greater than that particular threshold, it will give us the value. So what here at the rate is doing? At the rate is the reference for external variable. Okay, external Python variable, right? So it will evaluate this. If I'm writing at the rate threshold, it will directly take this particular value. So now this is how we can also use the dynamic values, and it will what happening here is now we are minimizing our expression, right? We are instead of writing this many things, we are minimizing our expression here. Let's say instead of this one value, for example, I have a list. Okay, instead of the variable like this, let's say I have a list of top countries from that CSV file, but I'm making a different variable of and list here. Let's say Japan. Okay, comma India. This is my list, comma China. Right? Let me run it. Now, if I say df dot query country in at the rate top countries, right? So here, when I'm using in now, now this in goes for the membership testing inside the query, because now we do not have the one value, but we have the uh like like a list. So I want to go inside this particular list. I want to check everything, then access the value using the at the rate, okay, of that list, and then according to query, I want it to solve. Okay. So now what it will return us? It will return us the only value of China, Japan, and India, right? So what in is doing? In for testing the inside query of list, or a inside query of external list. And what this at the rate here, it will like access that, but it is accessing that particular external list. Understood? Is it going too fast? Should I take some more examples? Or it's fine with you all? I need responses, otherwise I will keep on doing. How I'll understand that you are getting it or not? At least say yes or no. Are you guys there?
No.
Hmm? Not understanding? Prashant?
Hello. Yes,
Yes.
ma'am. It's understanding. No issue.
No. Yeah, good. Okay. So this was about the data filtering and this thing. Now in this only, like I told you, query we have covered, and the third topic is the string filtering. Like here it was, I think. Uh, this is the third method, string. This is the like this. ILOC and this thing will come together. Okay. This is kind of a string filtering, not a string method, but string filtering. Same only, string filtering. Now, when I say string filtering, so obviously we are going to work with the string only, right? Like here we are having string as a country, city, continent, and all this thing. So what pandas do, it exposes the string method through some .str, or instead of writing a loop or applying anything, okay, you can uh, apply some functions, or you have to add many more directly on a string column, something like that. So in string filtering, what we will do, it will same, like it will return the value with some, let's say, either we can change the, like a column name, or instead of this, I want to write that, or editing all these things. So based on this, like what we are doing, let's say here, let me tell you with the example how we are filtering using the string. There are various methods in the string to get anything out of it. Let's say the third is the string filtering. This is the third one. This was the second one. Actually, in string, no, there are 4 or 5 methods. If uh, if I'll teach now, it will take around 15 to 20 minutes. So, like in the next class, is it fine if we start the string filtering? Today, so many people are also not there. I don't know why.
I think today only very less numbers, I think.
Yeah, many less people joined today. Only 3 only.
Maybe I think tomorrow is holiday, no? That's why maybe they're traveling, I
Mm-hmm.
think.
Yeah, maybe possible. So, actually, the time also has been now over. So, I was thinking I'll start the string filtering in the next class, because again, it will take around 20 to 30 minutes, around 15 to 20 minutes. Is it fine with
Okay,
you all?
ma'am. Okay.
Okay. Thank you, guys.
Ma'am, one thing I want to ask
Yes.
actually, whatever your data accessing, no, this is a wild data or which one, ma'am?
Which, this one?
Yes, ma'am.
Huh, what data you're asking?
This is a wild data, right?
Huh?
Okay. Actually, we don't have this, I think, in that particular
It will be
whatever.
there. I have shared this file only. It will be there, world, cities, pop. This is just a random values, not a exact data, but some, like a hypothetical data. It is not a true data, but it is there
Oh,
in the file.
I think I checked, it's not there, I think so.
It's not there, then then I'll share this file in the group. Just like
Um,
world, cities, population data, something kind of CSV file. You will get it. It's not there. Then I
no, I
will.
think yesterday only I checked to practice that actually, but I didn't
Huh.
get this actually.
Okay. So, I will share this thing. Okay. This setting coordinates we have not used, I think, this data. Okay, fine. I'll share this in the group only. See, 2 kbits, so not a big deal to share.
Wait, ma'am, 1 second, I'll tell that.
Yes. Yeah, check this from this particular. Actually, it got so many.
Mm, yeah,
Uh, this
now, actually, CT is copy, CT CSV,
that copy
city.
by randomly it got copied. No, we don't need this copied
Yeah,
version.
okay, okay.
The
I
same
think
only.
21st March. Okay, ma'am. Actually, world cities pop.csv, right?
Hmm?
World cities dot pf pop CSV, right? That is the folder name. Yeah, actually, it's have actually.
Underscore.
Yeah, yeah. Yeah, underscore actually.
It will have this data like country, latitude, longitude, area, and quantity, continent. The which I am using now is the same one.
Oh, later you added multiple columns, right? Okay.
Later we are adding and like adding, removing, dropping
Yeah,
something. So then the file
that
is
some
getting
of
changed. But the
some
original
of the
one is this.
populations and all you have done summation and everything.
Mm-hmm. There is this
Okay,
nan
ma'am.
value in between, this the gap value, which is giving us the nan in the Python file. Okay, this value
Yeah,
here.
correct, correct. Okay.
Yeah.
Yeah, sure, ma'am.
Okay.
Thank you.
Yes. Okay, guys. We'll
Okay, thank
meet
you.
on
I'm
a
happy weekend.
Monday. Yeah, you guys also enjoy your holiday. Also do
Yeah, thank you.
assignments if you get a time. And if you come across any issue with the question or doubt, do let me know. Okay. Do not get panic
Yeah,
while
sure.
answering the questions. We'll discuss them.
Yeah, sure, ma'am.
Okay. Thank you so much. Bye bye.
Thank you.